Yeah, today I would like to talk about the dynamics between corals and algae. And I'm just going to explore the roles of climate change in driving those dynamics. I think one of the most important processes in coral reefs nowadays is the dynamics between the algae and the corals. And this is because the abundance of both, the algae and the corals, actually determines the status of reefs. So, I mean, if we imagine a healthy coral reef, we imagine lots of corals, high coral cover. But if we think about a degraded reef, we immediately relate it to a reef with lots of algae, high abundance of especially fleshy seaweeds. And yeah, there are a series of ecological processes involved in these shifts from corals to algae. And in particular, we have reduced herbivory due to overfishing and diseases of sea urchins. And this is the classic example from Jamaica by Terry, where we see the decline in the corals. We have the consequent increase in algae, and this was triggered by the disease or mortality of this sea urchin. We also have coral disturbances such as cyclones and coral diseases, and in particular coral bleaching are quite important in driving those dynamics between the algae and the corals. These are some data that we collected during the 1998 coral bleaching event in the central section of the Great Barrier Reef. So we have here the percentage cover of the corals. We see how these corals decline in response to bleaching. And then we see the increase in the algae, right, in response to this decline in the corals. We also have eutrophication. Eutrophication has also been related to algal blooms, but to a lesser extent. This is a model put by Dave Bellwood here. This is just to illustrate the concept of ecological phase shifts, where we have these systems that could just move from one state to another. And I just showed you a couple of examples of reefs that have moved from this healthy state with lots of corals to a macroalgal dominated state, right? So there are a lot of examples of these shifts and these processes. However, we have very few examples of the reverse. There are few cases, few reefs that have flipped back from this macroalgal dominated state back to this healthy state, and that's what I would like to talk to you about today. Is about an example, an exceptional example of this process. So during the 2006 coral bleaching event, the reefs here in the southern Great Barrier Reef experienced quite a lot of bleaching. Here is the place, the locations where we worked at, the Keppel Islands. So it was bleaching triggered by increased sea surface temperature. This is one of the photos that the group took during the bleaching event in 2006. This was just a massive event. And a close-up to that reef reveals that there was a lot of brown alga, the brown alga Lobopha variegata, which was kept in kind of in low abundance due to the competition with the corals. But as soon as the corals died from bleaching, we had a massive increase in the abundance of this alga, and this is because this alga was released from the competition with the coral and just basically overgrew the entire reefs. So this is some of the photos that we took during that process of replacement of corals to algae. And this is just to put some numbers here. We see the decline in the corals here that went from 80% coral cover down to 20%, and we see here the consequent increase of benthic macroalgae. A year afterwards, we were quite astonished and surprised by the recovery rates of these reefs. So there was quite an spectacular phenomenon. Here, just to put some numbers here, we see the corals here bounce back from this very low coral cover, while the algae just basically decline. And this process happened in several reefs, in Halfway Island, Barren Island, and in another reefs in the region. However, in one of those reefs, the actual reef didn't recover from the algal bloom, and it just basically stayed in this algal-dominated state. It's one of the most interesting things of this story was not only the recovery, the fast recovery of the corals, but also the mechanisms by which this happened. So we identified 3 key mechanisms by which the corals recover, and one of those was the seasonal dieback in macroalgae, right? The alga Lobophora variegata, which is growing here amongst the branches of the corals, is a winter species, which means that it grows quite a lot during the winter time, right? And then it declines during summertime. And we have done a series of experiments looking at the effects of increased temperature on the physiology and growth of this alga, and this alga doesn't really like the summertime. And this also happened in other reefs. So that was one of the key elements of resilience in our system. The other very interesting thing was that the corals experienced quite rapid regrowth from remnant coral tissue. So this branch here died from bleaching. It got overgrown by seaweeds, in this case algal turfs. And then some of those corals that remain at the base of those reefs actually regrew back upwards, and they excluded competitively the algae that had settled on those branches. And you see here how those injuries kind of healed until they completely kind of recovered coral cover. These are some data from Ray Berkelman's collaborator in our team, and he was comparing the calcification or growth of the coral in the Keppel Islands, right, compared to a reef compared to an offshore reef. And we see here, the corals in the Keppel Islands grew twice the rate of the corals in Davis Reef. So these corals living in this place can have a very high rate of growth. The other mechanisms is that these corals have quite a high competitive ability. They manage to competitively exclude the algae. We see here they excluded the algal turfs, the filamentous algae, right? They pushed away and in some cases overgrew the fleshy seaweeds Lobophora, and they even overgrew the coralline algae. So these corals really had a spectacular ability to get rid of these seaweeds. So, because this is just a speed talk, so I'm just a very brief talk. So, let's come up with my conclusions. So, our study here provided some valuable insights into the variability and mechanisms of coral recovery under rapid climate change, and here we're illustrating that there are a bunch of other elements of resilience that need to be considered when talking about the recovery of reefs. And also our study showed that managing local stressors such as overfishing and looking after water quality and so on does help the reefs to bounce back from disturbances. So I'm just going to leave it there. Thank you.